Hello, my name is Tu Yanes, and today I would like to present about our projects. For This is the project. It's called the Orchestronic, which is a platform that make the cloud setup and the app deployment super simple. S- The problem that we find is that developer wait days for servers and database setups. Managing AWS and Azure cloud services is a mess. Kubernetes is too complicated to set up, and all the CI/CD tools don't work together. Everything is manual and inconsistent. So our project Orchestronics solved this problem, which is we call this Orchestronic project called the Internet Developer Platforms, which is basically your own private cloud. Developer clicks the buttons to request the server, database, or Kubernetes clusters. We set up automatically on the Azure and AWS cloud resources, but we don't use their managed services. We rent basic hardwares and build everything ourselves, like having our own servers. You can push code to our own GitLab server, and it builds the Docker image and deploy to our K3s cluster automatically. So as a result, the code pushes can go live in minutes. Uh, you can control everything you want. So why do we develop these projects? Uh, our team kept seeing this developer wasting time on infrastructure instead of the codings. Our project got delayed by the manual setups. We wanted to build the real IDB, like big companies with their own data centers have. But we are a small team. We can afford our own servers. So we use the cloud resources differently. We avoid AWS and Azure pre-built services. We ran their missions, but we set up our own K3s, our own GitLab servers, everything. We get control our own servers. Plus, the cloud flexibility and lower costs. That is our real IDP. So here's what insights our applications. So basically, we have the set up the front end as a Next.js and the Next.js APIs, and we call to the Airflow Apache Airflow servers, which is built on the setup on the cloud. We use the Apache Airflow server as the running the automation scripts to provision the cloud resources, such as the Azure VM, SQL databases, storage accounts, and on AWS Cloud, we can set up by using the Apache Airflow, such as the K3s server, the K3s Kubernetes clusters, uh, Amazon EC2 servers, RDS database, and the S3 services. And we also have the GitLab servers, which is our own self-managed GitLab servers. We can push code to the GitLab servers, and we can run the automation script CI/CD scripts on the GitLab runner, and we push the image to the GitLab container registry. We can then deploy our image into our own K3s clusters. We use the database as a PostgreSQL from the Supabase cloud service. So this is the overall architectures of our applications. So next thing is we would like to demonstrate how our applications works.
Okay, so basically we have roles in our Orchestronic platform here. So first of all, we have to sign in with the Microsoft. So you can sign in with the Microsoft, and you can select any account you like. So here, this is our account. So we set up the role for admin, and there's another role. We call it developer. So here, this is a developer role, and we have our GitLab here. So you can create an account here, and you need to link your GitLab profile with a Orchestronic application. And then after that, you can create the request here. So here is our Orchestronic dashboard. So we show a list of requests along with the repository here. Let's dive into request. So here is our request for the projects and request for the clusters. So let's talk about the project request first. So when you click the request here, you can choose one of two options. Let's talk about project first. So here you can, when you click the create project, you can create the repository, and you can create the resource group. We have virtual machine storage and databases, and you can create one or multiple, anything you like. You can um, like do it like this. So let's talk about the repository first. So let's name it uh, okay, demo. Uh, let's say pre-demo. Okay, and then you can give a description of your repository. You can even add collaborators here. So in my case, I will collaborator anymore, and I will create a database, which will be Azure provider, and region is in the Singapore. Okay, I select a database. I name just like that. Postgres SQL. You can select any size you want. I will select just small, and username will be the same. Password is like this, and yeah. So for the storage, we provide 32 gigabytes and 64 gigabytes. So I would just select this one, the smallest one, and you need to give your request when you want to create this request to the admin. So this is for the demo budget testing. Okay, and then you can uh, click here. You can submit your request. Okay, so request is created successfully. So let's go to the admin here, and let's check. Okay, so the pre-demo request is already here. So you can go inside it, and you can see that this is the requested database and the repository. So when you want to accept it, you can just you cannot accept until you give a feedback. So okay, hold on. And then you can click approve. Okay, so it is now creating a repository. So it is successfully finished creating a repository. So let's go back to the request in the developer side. So you can see that this is the request that we already created, and it is approved. So let's click the repository here. Okay, so we can see that the repository already created, so which is pre-demo here. It is already in my account. So let me try to upload the Demi Nest.js application to our GitLab repository that is already freshly created. Okay, so here is my terminal. Uh, let's try to add the remote first. Okay, this is the first comment here. And then okay, so we need to push to the master branch. Let's try to push it. Okay, so let's see the update here. We refresh it a bit. And here you can see that I already created a Next.js application with the Docker file and GitLab CI file. So we already set up the GitLab runner here. So the runner will track this file, and then it will just run the script here. So right now, you can see that the runner is successfully running the script. So let's wait until we finish the image build and push to the container registry success. Okay, so it takes around like 10 minutes and 42 seconds. So let's say around like 11 minutes. And yeah, we have successfully finished the CI script. So now that we can see the image in our container registry, okay, here. So which means that the image is ready. So let's go back to the Orchestronic and let's create a classroom. Okay, it's already signed up, so we need to sign it back. Okay, so uh, in order to deploy application, we need to have clusters. So let's create a cluster. Okay, so we need to create a resource group first. So pre-demo. And for now, we're using cloud provider for AWS since we got uh yeah. And okay, the region is Singapore, and we already have number of clusters. You can do like as much as you want. So in our case, we just set like one cluster. And for the cluster name, we just set like pre-demo cluster. And you can also set the number of node as you want, but I will be setting one here. So for the VM size, right now we are providing T3.micro. So you can select the T3.micro here. And we try to create the cluster request here. Okay, so it will show the cluster creation request submitted successfully. So we can go back to our admin and you can see we can check for the cluster request. So here, pre-demo is already pending state. So yeah. So the admin can now approve the cluster request. Okay, so let's approve it. Okay, so let's go back to our request and see the cluster, the approved one. Okay. Okay, here. So when we look inside of it, uh, okay, so it is approved, but you can see that the kube config here is not appearing. So what does it mean by that is that we cannot deploy on the cluster for now. So we need to wait for the kube config to be available for the deployment. Okay, so now that it is from issue that from pending state to configure state and kubeconfig is available, so we can start deploying our application. So let's go back to our developer side. And yeah, you can go to request. Let's toggle it down. Okay, so here, let's go to our pre-demo. And when you toggle it down, okay, you can see that there are too many deployment configuration. So the provider is already AWS, and you can set the port here. If if you're using the private repository, you just have to click on it. But since we are using a public repository, we don't need that. So for the port, we set it 3000. And for the target cluster, we use this one, which we already created. Okay, so we can start applying it. Okay, so now that deployment is success, you can like copy it here, and you can try to like paste. Okay, so you can see that our application is successfully running on the cluster. So this is our cluster name. This is our project name. And yeah, so which is successfully running. So yeah, so in order to for the admin part, in order to monitor those kind of applications running or not, uh, we are using the Apache Airflow for the monitoring. So I will just show it.
So in here, we can, once you deploy or configure every cloud resources we will use these scripts, like the Apache Airflow script files. And for our cluster provisioning stuff, we use these three uh, configuration scripts, which is the AWS, which is the AWS resource cluster. And in here, it provisions the AWS VPCs, subnets, all the AWS network resources that require for uh, Kubernetes clusters. And another script is AWS Terraform K3s provisions. This ones is we use the Terraform scripts. We include the Terraform scripts to provisions the K3s clusters. We set up the EC2 servers and install the K3s installations to set up the Kubernetes clusters. And another one is the configurations. In here, we use the Ansible to configure the provisioning K3s clusters by installing the required installations, such as the load balancing stuff, and also the K3s installations. Those will be configured in here. So for the load balancing, we use the Trifix offices. Yeah, this is the three scripts that we basically use to configure the clusters. You can monitor in here uh, whether it is successful or not. If we have the fail states, we can configure it in here. Uh, okay, so this is all for our projects is about. So here's our team is called the Pipe Piper. We have three members who contributed into developing this project. My name is Du Yanes, and we have the Tao Shines and also Hein Dance. We are the students from the APEC final year IT students from the Assumption University of Thailand. Thank you very much for the listening.